Hello, everyone. We're going to be starting with macromolecules. This is our next unit as far as in the course for anatomy and physiology. Macromolecules, generally speaking, I don't think is too difficult. It's mostly about reviewing biology. So we're learning about molecules that are essential, especially these essential for life to exist. So what are the goals for this unit? Let's see. Oh, sorry. Forgot I have the pen. The goals for this unit, describing the basic structure and function of the four major macromolecules. That is definitely the major goal. Understanding the role enzymes have in the body and explaining the factors that can affect enzymatic activity. So if there's two goals related to enzymes, obviously they're important. We're going to talk a lot more about enzymes in digestive system, but if you've taken biology, if you've taken chemistry, enzymes, you should be familiar with them, no doubt about it. All right, so what are the macromolecules of life? So, as I mentioned in our little introduction, the macromolecules of life, these are the essentials. They're necessary for all living organisms, from a single cell all the way up to us, the apex. We're the most complex creatures to our knowledge in our known universe, right? So, what we really need to pay attention to, I'm going to go ahead and circle some stuff for us. The following elements are essential for all life to exist. Now, if you're taking chemistry, you should be familiar with the periodic table. If you've never taken chemistry, it's not a big deal. But these are top dog, no doubt about. Carbon, oxygen, hydrogen, nitrogen, phosphorus, and sulfur. Those six are the key structures or the key elements that are going to make up these macromolecules that we're learning in this unit. Carbon is found in almost everything. Carbon's found in organic compounds like us. Carbon's found in inorganic compounds like this pen that I'm holding. Oxygen, it's in the air we breathe. Obviously, we need oxygen for survival, but there's more to it than just that, as we're going to learn in this class. Hydrogen, it is also a gas, so we do breathe it in, but most of the hydrogen reacts with other compounds to form other materials. So, for instance, one of the combinations or one of these reactions that a lot of us are already familiar with, two molecules of hydrogen, one molecule of oxygen, H2O, water. Nitrogen, phosphorus, sulfur, those are typically more earth-based compounds. Nitrogen can be found as a gas as well, so we do breathe in nitrogen, right? But as I mentioned, these are all the essential materials. Now, those materials end up creating these four. So we have our carbs, we have our lipids, we have our proteins, and we have our nucleic acids. Now, for our purposes, I'm not necessarily going to ask you like, hey, make sure you remember that proteins have nitrogen and et cetera, et cetera. But it is important to recognize that there's a common thread here. Carbs, lipids, proteins, nucleic acids, all four of them have at minimum carbon, hydrogen, oxygen. Those are the essentials, and then you kind of build up from there. As you get more complicated, proteins have nitrogen and sulfur. Nucleic acids have nitrogen and phosphorus. So as you get more complicated, you start adding more elements in there. Okay. And why I find this so interesting as far as what we talk about with macromolecules, I'll clear this out of the way for us for now. These elements that we're discussing, because we know that they provide life, if you go back to the earliest days of Earth existing, Earth was nothing like it was today. Earth was volcanic, toxic smog everywhere, magma, lava, etc. Nothing could survive. But the right elements were found, the right molecules of these compounds were found, add a ton of heat, and you can create single-celled organisms. And eventually evolution will do the rest, right? Knowing that information, what I find fascinating is that it allows us to look elsewhere, right? It allows us to contemplate what other planets could we find. Mars has already been proven to have many of these key elements that allow for survival. Granted, it's stuff we're finding in the soil in Mars. It's not like you land on Mars, you can walk around without a helmet or a spacesuit and you'll be fine. That's not how that works. But the theories are showing that Mars very likely a long, long time ago used to be similar to Earth as far as its structure and as far as its composition, and possibly even housing life. What type of life are we talking about? I doubt complex life like humans, but life can be single cell organisms, right? So I do find that very interesting. That is something that grabs my attention. Okay, carbs. Carbs are our first unit of macromolecules that we're talking about out of the four. First and foremost, I would make sure that we're familiar with this basic unit of carbs. We have sugars, otherwise known as glucose. You can kind of see it right under there as far as the chemical shape of glucose. This is like stuff you'll learn in college if you pursue this. This is like a ring and all that fun chemistry stuff. We're good. We don't need to worry about that for now. But your basic sugar, your basic carb is going to be glucose. When you see words ending in OSE as a suffix, that's always indicative of a sugar. And you're going to see other words like that in my class, and you may have heard of other words, right? Sucrose is a common one. Fructose is found in fruit. Lactose is found in milk. We're going to get into more of this. Dextrose, etc. So what's the point of a carb? A carb, one of the major things that it does is that it provides energy. Your body loves carbs. Carbs are an incredible source of quick energy. That's one of the best things that they provide for you. That said, it's not the best long-term energy. It's more for short-term spurts of energy. I always think of, when we were going trick-or-treating, can never be too old for trick-or-treating, right? But when we were trick-or-treating, you get your bag of candy, you get home, you start eating a bunch of chocolates and candy. You get that sugar rush and it spikes you up, but then you crash back down really fast. Another reason why, like another example, those of you that play sports, I guarantee your coaches have told you prior to a big meet, prior to a big game, prior to whatever, hey, carb load. And we're talking about like the night before. If you eat a ton of carbs the night before, that provides you with stored energy so that when you need it, when you're performing, you're ready to go. You got the energy to boost and to actually perform well without burning out. Carbs are also a great structural unit. They're helpful for building more complex structures, which we're going to learn eventually down the line. One of the most important carbs that I'm going to go and star this here, one of the most important carbs that we need to know is fiber. Fiber is an essential complex carb. So these complex carbs don't process the same way that simple carbs do. The biggest thing about being a complex carb is that it helps to prevent constipation. It helps to keep a healthy flow. I cannot tell you how many people I've talked to that will tell me, yeah, I don't usually go number 2 except for every other day. If that's the case, you need to take some fiber immediately. You need to start improving your large intestine and improving the health of your colon, because that can cause some serious problems down the line. The foods that have carbs, without a doubt, most people based off pop culture are going to be saying bread, pasta, grains, rice, cereals, no doubt. But don't forget that carbs are also sugars. So we're also going to find it in fruit, because a lot of fruit is naturally sweet. We're going to find it in seeds. We're going to find it in processed sweet stuff like your candies, your cakes, your donuts, etc. And we also find it in veggies too. Certain veggies are better than others as far as carb concentration. My rule of thumb is that if it grows underground, it's going to have a lot of carbs. It varies a little bit. Carrots don't have as many carbs as potatoes, right? But the more starchy something is, potatoes, sweet potato, yucca, that's all going to have higher concentration of carbs. Last but not least, very, very important right here, glucose, sugar, right? The way your body likes to treat sugar, and let me give you a good analogy. You go to a restaurant and they serve you your meal. You love the dish. The dish is the best thing you've ever had. But you feel kind of bad because you didn't finish your meal, right? You still have food on your plate. You don't want it to go to waste. So you tell the waiter, can you get me a to-go box, please? I want to save this for later. That's your body with carbs. Your body's going to utilize as many carbs as it can in the moment. Keep you functioning, keep you going. But any extra that you consume, your body wants to hold on to. So your body converts extra glucose into a compound called glycogen. Glycogen is a more stable version that you can maintain in the liver. Liver plays an important role with a number of different systems, and now we're starting to slowly learn what it's involved with. And when do you notice that glycogen is used? Every single day. Take, for instance, let's say it's about 10:30 in the morning. You woke up at 7 or so, assuming you have school, right? You woke up at 7 or so. You didn't have breakfast, didn't even have coffee. All you've been having is water. By 10, by 10:30, 100% your stomach's grumbling. You're getting hungry. Your blood sugar is starting to lower. Now, instead of letting you pass out, because hey, even me sitting here and talking is burning energy, instead of letting you pass out, your brain tells your liver, time to secrete glycogen, aka blood sugar. We need sugar right now. And that keeps you going. Now, when the glycogen runs out, when your glucose storage runs low, your body still needs energy. You're not just going to say, oh, well, I guess we're screwed. You still need energy. So, as we're going to learn in our next video, your body will then tap into what's called the long form energy, or the long method of energy: fat, lipids. Fat or lipids is highly sustainable. Obviously, you don't want too much of it because that could be harmful to your body, but you want a good concentration of it to keep your body functional. So we're going to learn more about that as we progress. But guys, that's a good place to stop. We're not getting too crazy with this. This is a short unit. It's going to be about the same number of videos as our first unit for Intro to Anatomy. But as we progress, as we get into our next unit with integumentary system, yeah, then the length of videos and everything like that will get a little bit longer. But this is a good place for us to stop for today. Other than that, thanks for tuning in. I'll see you guys in the next one.